Good morning, good morning, good morning. Hope all is well. Hope everybody's doing all right. Gonna give everybody a chance to get in before we get started. So let's give them a few seconds. All right, looks like pretty much everybody's in. So good morning. Hope all is well. Hope everybody's doing all right. Hope everybody's ready for this new semester. My name is Mr. Tucker. I will be your instructor for this semester. So evidently, you guys have been getting my either you saw my emails or you saw my information in Canvas announcements. But just in case you didn't see the stuff in Canvas announcements, let me go ahead and show you where that is. Dashboard. Yeah, appreciate it for those who are enabling your cameras. Don't get that often. Yep, yep, yep. So right here, Canvas announcements. You go to your, well, y'all don't have all, well, you may not have all these types of windows. So you depend on how many classes you have, but you just go to announcements. And every email that I send you guys, I will archive here under announcements. So we see that our first four emails, course description, and just the Zoom information were here. Let's see. I want to actually come back. Okay. Okay, not a problem. So yeah, so every email. So if you ever in a position where you haven't heard from me in a while or you haven't seen anything, you can always go here to see if I have sent anything. I will archive any email that I've sent to you guys in your announcements here. So this first one is just agreeing to let you know how the class will be ran. That this class will be ran virtually, not necessarily online. So the difference between the two, if you're talking about online class, is not a class that necessarily has to be met at a certain time. Online classes, they can send you a video and you can actually just can now see. Okay, I think it was because the person just came in. All right, so and the teacher doesn't necessarily have to teach live, but when you're learning virtually, your class will be held at a time that is normally held at, synchronously. And so every class time, every period, we are expected to meet 9:30 Monday, Wednesdays. I'm going to be here teaching live. Your class sessions will be recorded. So if you were to miss a session, I will be recording the lectures and then converting them to the YouTube link. And then I'll send that video to you before the week is out. So if you do miss a class, then that will be afforded to you. Let's see. Oh, also, I know there were a few people, one or two people that I did not have emails to. So hopefully, you were able to get here and get your information. But if you didn't receive an email from me, that's why they didn't have emails for you in SIS. So you do want to check that out. So yeah, any questions on that before we look at these last two that I sent? Everybody good? Everybody straight? Okay, let's look at required materials. Talk about this math lab. All right, so I sent this one out. You guys' course ID was different. This is not accurate. It's just a generic email that, this that was for another class. But just talking to you about my math lab and getting registered for it. We'll go into that in a second so I can show you the process. But you go to my math lab, click register as a student, and then type in the course ID. So from there, once you put in all your information, you have three options in order to register. Some of you have already done this, but just want to make sure everybody's clear. You have an access code that you either purchase from Barnes and Noble, purchase from a friend or Amazon, some outside source. You can type in, it should be 16 digits. You can purchase access through Pearson itself, in which they won't give you a code, they will just give you the access. Or if you're not ready to do either with the access code, you can use the 14-day free pass. which will give you full access for 14 days. Once 14 days are up, it will lock you out if you haven't, not ready to purchase access. You will not lose any of your progress or any of your submissions. I will still be able to see them, but you guys won't have access to it until you actually pay for the 14-day free pass. I mean, until you actually pay for full access. Sorry about it. All right. Any problems with that process? Everybody good? Everybody straight? All right. Last email that I sent, MathLab specifics. Just talking about how we're going to use MathLab. You cannot pass the class without access to MathLab. All of your assignments, tests, whatever we do will be generated through MathLab. And if you don't have access to it, then of course you won't be able to make your submissions. Um, also, your attendance will be solidified through MathLab. I will look at attendance through Zoom. But remember, I told you I would be recording lectures and then sending them to you guys. So that means if you were to look at the lecture later on, I would not know about it. But to me, that's the same thing as sitting through the lecture. So the way I will solidify your attendance will be through MathLab. So that means, let's say if you were to miss both classes in a week, in order to make sure you're good, just go into my MathLab and hit submit, hit save a homework, just get a timestamp on your attendance so that I can go through MathLab and see that you were active that week and there's nothing, nothing you have to worry about. So you always want to make sure you have you are active in my MathLab and there are no questions about, your participation. When it comes to homework, oh no, before I go there, if you're having any issues with MathLab, always let me know. In other words, if MathLab go down, because sometimes it happens, servers, technology stuff happen. Let me know so that I can address the issues accordingly. We will have due dates, especially if MathLab go down on a due date weekend. I won't know unless you tell me because I'm not doing MathLab homework. You know what I mean? So if I get enough of y'all say, hey, stuff went down, or just one person let me know something went down, something I will investigate. And and if I have to move a due date, then that'll happen. It's not a big deal. But I won't know unless you guys tell me. Um, let's see. Oh, and then if you're having personal issues, every semester I have people that fall off the face of the earth. You know what I mean? They stop emailing, they stop communicating, they stop coming to class, they stop submitting, they stop everything. They don't withdraw. I have no choice but to give those people Fs. If you are not that person, you got to let me know so we can work something out so I can at least know this person is not that person. You know what I mean? So keep me in the loop. You don't have to give me deep, intimate details. I do not have to know everything. Just let me know I have a little struggles, having little issues. I want to make it work, want to make it happen, and I'll do whatever I can to help you guys out. But I just need to know that you're not that other category of person that's just going to get down. You have unlimited amount of tries to get the best grade possible on your homeworks, and I'll show you that in a second. When it comes to your homework, 75 to 84.9 will be a 90% in my grade book. My math lab won't reflect that. That's something that I do at my final grading. Then 85 to 100% is 100% full credit. So if you want to get that full credit, at least shoot for 85. But if you want to get credit period, which is an A, shoot for at least 75. Now remember, I did send this to you guys. So if you ever lose these numbers or whatever, always go to your Canvas announcements that'll be in there or in your emails. Notice I didn't mention anything less than the 75. That's because with the unlimited amount of tries, there is no such thing as unlimited amount of problems. So let's be honest. I'm not oblivious to the process. If you keep clicking, 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 you'll get the problem that you just did, that you got the answer to. So I know for a fact if you really wanted to, you could just get 100 and you wouldn't even done anything. But we know that's not the real process. But if you're trying to at least get a 75, it shouldn't be that big a deal. I'm just letting you know I'm real. I understand the situation. So we at least want to shoot for 75 so you can get credit on your assignment. Test reviews. There will be a test review for each test. You do not have to do them. It's just, I would suggest you at least go in there and look at them so you know what's on the test. But they're not mandatory. But if you score 85 or better on that test, I will add 5 points to. Now, if you score 85 or better on the review, then I will add 5 points to your test. But once again, if you don't do them, I will not look at you sideways. They will not affect your grade. Let's see. You get 2 attempts to get the best grade possible on any test that I assign that's not proctored. Your first test will not be proctored. In other words, I'm not watching you. You can do it on your own time. Proctored tests, we'll talk about those later, how we will handle those. But you know, the easiest thing to talk about right now are non-proctored tests. You get to do them on your own. Like I said, you get 2 attempts to get the best grade possible. And then any submission on any test, whether it's proctored or non-proctored, you want to shoot me your scratch work. All right. Any questions on any of that before we go look at my math lab? Everybody good? All right. Always feel free to email me if you have any questions that may have been generated, may came up after this conversation. So, like I said, we go to my math lab and you get to this screen. You guys will click register now as a student. Okay. Let me make sure I'm on the right thing. Yep. So here is where you would type in that course ID that I gave you guys. 71774, 71774. Type that in. So notice here's your course right here. So if you already have a Pearson account, go ahead and use it. If not, you hit create, type in your information, and then from there, you'll get those 3 options where it asks you for the access code or purchase access. Or if you just want to do the 14-day free pass, there will be a little blue, wording down here at the bottom that gives you access to the 14-day free pass. All right, questions on registration? Good. All right, so once you get in there, here's our course. See 15 already enrolled. That's good. That's good. All right. So here's where all of your stuff is, your syllabus. This is an old syllabus. I just haven't updated a few dates. Content and everything's still the same, but the section is 02, different things like that. So I just need to readjust that, but that's same content if anybody needed it. Homework is right here. So here's all of your homework for the whole semester. So this class focuses on chapters 1 through 4. Pre-Calc 2 starts at chapter 5. So if you know you're going to take Pre-Calc 2, before you purchase another Math Lab code, you should be able to use this one. I believe you can use the same code twice. And Pre-Calc 2 uses the same book. So if you're going to use the same book, you can still use that same code. So just throwing it out there, next class, when you guys go to Pre-Calc 2, before you go buy a new code, make sure you try this one first, this access code first. You should be able to just register really, and it should let you in without using that access code and everything. We're just throwing it out there, try to save you guys a little, a couple of dollars. Let's see. So notice the due dates here, 12/17. That's the last day of class. Now, that's not going to stay that way as we get closer to closing out this chapter. Let's say around 1516, I'll put a due date out there. Normally my due dates are on Sunday night, but I didn't want to put a due date out there. And let's say we need to move a little slower, and then I have to adjust the due date. Well, just why put one out there when I can just adjust it to this class? And so that's what will happen. And what'll happen is for every due date that we have, there will be a block of homework, a block of assignments due. So chapter 1, all of chapter 1 will be due on whatever due date we set up. And then when we get to closing out chapter 2, then there will be a due date for chapter 2's assignments. All right, so that's how we'll deal with our due dates. So right now, we don't really have one. When we get closer to closing out chapter 1, then we'll put that due date out there. Chapter 1's test is already posted. That will be included in that first due date. Notice here it says 0 2 attempts. Your first test will not be proctored. It will be something you can do on your own. And that due date once again will be adjusted when we get closer. Now notice here, sample tests and quizzes. I cannot remove these. If you want to do them, you can, but they do not affect your grade. I wouldn't suggest wasting time because you have enough stuff that will focus you on what we want you guys to achieve coming out of the course. But I just want to make sure we understand that says sample tests and quizzes. And there's nothing I can do with that. It's something embedded in my Math Lab shell, and I can't delete them. So you're just looking at what's above that, which is just the test right here. All right. Any questions on homework? or quizzes, tests? Very good.
I forget, what was the password for, the ID for math test?
Or the course ID?
Yeah.
It's Tucker 71774.
Tucker 71 what?
774.
71774. Got it. Thanks.
Yep. Somebody threw it in the chat. Thank you. Thank you. All right. So let's look at an assignment. All right, so this is a preview of an assignment. How things will look for us. Let me go to a real problem. Yeah, this is good right here. So here we have a problem. I go ahead and click on it. Let's put answer 2. You go ahead and check your answer. They try to give you a little hint on how to do it. Give you another chance. Notice now it says final check. So you get 3 chances to get the answer correct. On most problems, most problems that involve calculation. I'll show you one that doesn't do it in a second. And so then it tells you what the correct answer is and what your answer was. Skill builder would be something that's generated once you've done the actual assignment, once you complete the assignment, and that'll help you build up your skills if you want to, take advantage of that. Down here, excuse me, are your help tools. You can do help me solve this. Most people don't click on that one. You only click on that when you're completely done with the problem. You're frustrated, you can't do it, you can't figure it out, and you just go ahead and click on that. That will walk you through this problem itself. Once it does that, then it will reset the problem and give you another one. Viewing examples, what most people like to click on because it gives you a window of a problem, outside window of a problem that's very similar to it. And then it'll walk you through a problem very similar. And then you can go back to the problem you're working on. Some people even print this out, so you do have that as an option as well. And then if you want to get more help, some problems, depending on the complexity, will have a video textbook that will send you to the place in the e-text where the problem is actually discussed. Ask My Instructor will shoot me an email. You can try that one out. Sometimes I don't get them. It's a little sketchy sometimes. Most of the time I do, but every now and then I don't get them, or at least somebody will tell me they sent me an email through that and I don't get it. So if by some chance I don't respond to an email that you did ask my instructor for, always feel free to, email me the conventional way, whether it be through my TCC or through Canvas. I do get those. Here you can print if you want to print it, and then there's skill builder again. All right. Then here, this is the list of all the problems in that section. You will have a red X beside that problem until you get it right. Once you get it right, then it'll be a green check. All right. So now if you go back to one of those like type of vocabulary type problems, let's say I'm just picking anything. Notice it says final check. You only get 1 chance for those. You get it wrong. And see, they give you the answer, but when I reset it, let's say try again, it's the same problem. So that's why they only give you, one answer to that, one shot. So maybe it's unlimited, so you can just go back and do it. So now see how we have a green check for the one that we have right, red X for the one that we got wrong. And yep, and you get full credit once you get it right. Be like you never got it wrong. All right. So any problems or any questions on anything I just did there? And then also something like this, you see how your help is limited because there's really not much to it. So, all right, everybody good, everybody straight. Let's see, anything I need to focus on before we go? I think that is it. Any questions before we look at the notes? Any questions?
May I? So with these homework assignments, when you're attempting to complete them or something, does it save the progress of how much you have completed?
Yep. All you have to do is hit save, and it should save it where you left off.
Oh, I see.
Now, I'm glad you said that. Now, if you're doing a test, you are expected to sit in a test. So it does not save. You can't go in and out of tests, but your homework you can go in and out of with no issues. Yeah. All right. Anything else before we do a few notes for today? Mighty good, everybody straight. Okay. So, of course, if you have any questions on anything, always feel free to email me or ask next class. We'll make sure you're straight going forward. All right. So today we're going to look at 1.2. May finish it, may not. But I do want to go ahead and get you guys rolling in the lecture, and you'll see that oh my wrist. I'll walk through it, talk and write, just like we would be in a regular class setting. Some stuff I already have written, some things I'm going to erase and then write back, just because of clarity issues, make sure everybody's good on certain things. So 1.2, linear equations and rational equations. And of course, if you have any questions on anything I've written, if I wrote something too jumbled or whatever, always feel free to, ask. This section, talking about linear equations, I do go back a little bit, make sure everybody's straight foundationally. This section does not talk about linear equations with the idea that it's introducing it to you. So there may be some things that it does not hit. Always make sure you ask questions. This whole chapter 1 in certain sections, they don't really talk about it like they're introducing the topic. So there may be some things like you'll see, we'll talk about factoring, but it's not talking, we'll mention factoring, but it doesn't talk about factoring because they assume you know how to factor. So if you have any issues with anything that we talk about, have any holes or what you may believe to be holes in your, math, your foundation, always feel free to shoot me that email, whether it be we need to meet outside of class because you have some questions, or if you need to see a video talking about certain things. Like I said, let's say factoring, for example, I do have videos already generated that I had previous lectures on that talk about stuff from a more introduction standpoint. So just throwing that out there, just to make sure that you know that here to do whatever I can to make sure you guys are straight moving forward. So an equation is just a statement that two algebraic expressions are equal. And a light example of that is x plus 5 equal to 7. All right, just stating that two algebraic expressions are equal. All right, so the solution is going to be value or values that will make an equation true. So in other words, when I look at an equation, let's look at x plus 5 equal to 7. I want to know, when is x plus 5 equal to 7? Or in other words, when is that a true statement? And the answer is when x is equal to 2. And so you can always take, whenever you have a solution or what you believe to be a solution, you can always take that and plug it back into your original equation to see if it actually is true. And it should work out for you if it is a solution. All right, scrolling up a little. Always, if I scroll up and you're still copying something, feel free to type in the chat or even unmute to let me know. I'll try to do whatever I can to make sure I'm not moving too fast. So then we have what I call opposite operations. Could have wrote that a little better. Opposite operations. Addition and subtraction are opposite operations. Multiplication and division. Opposite operations. They are operations that undo what the other one does. So we'll be using that thought process to actually solve. All right, so let's go back to the x plus 5 equals 7. So your goal is to get your variable by itself. You want to have x equals 2 or x equal to, whatever your answer is. So you want to undo what's being done to your variable. I have x plus 5 equal to 7. So I want to undo the addition of 5. If that's what I'm trying to do, then the opposite operation will be the subtraction of 5. So now if I want to subtract 5 on one side of my equation, I have to recognize where my equal sign is. My equal sign sets apart the left side of my equation versus the right side of my equation. Whatever you do to the left side of your equation, you have to do to the right side in order to keep your equivalency. So if I minus 5 on the left side, I have to minus 5 on the right side of that equal sign. So the 5 minus 5 will cancel, leave you with just x on the left. 7 minus 5 is 2 on the right. And that is the foundation of solving equations. Your goal is to get your variable by itself. You're going to use the opposite operations in order to do so, and simplify whatever it is on the other side of that equation. Whatever you do to the left, you do to the right, and that will be your answer. Also over here, I was just emphasizing, I think somebody asked the question, you know, when you don't see anything in front of your variable, they assume you know that there's a 1 in front. So if you have if you have x, that's the same thing as 1x. If you have a, that's the same thing as 1a. So right here, if I have 2x plus x, they assume you know that's 3x because there's a 1 sitting in front of, you know, that x. So that's what I was emphasizing on that right side. Somebody asked a question. All right.
Professor,
Yep.
I am a little lost on where we're looking at. I can't quite find it.
When you say what we're looking at, what you mean? Can you see my note screen?
No, I just see the video feed.
Okay. Can anybody else having that issue? Can anybody else see a note screen? Can somebody do a thumbs up or something? Let me see. I see a thumbs up. Yes. So let's see. Okay. Let's see what I can do. I will try to unshare. Now, let me ask you this. Were you able to see all the math lab and stuff like that I was doing
Yes,
before?
and then all of a sudden it just disappeared and I have a column of just video feed of
Gotcha.
the Zoom meeting.
So everybody else said they're good. So let's see if this will help you. So can you see my math lab? I just switched to my math lab.
No, I mean, I'm on my math lab, but I can't see a screen that you would be sharing.
Yeah, you might want to go out and come back in and see,
Okay.
reset your Zoom connection and see if that'll help. All right. Okay, cool. All right. So while she's doing that, let's go ahead and look at this next one. And so we have y minus 5, y minus 10 equal to 15. So I'm just doing a few one-step equations before we add more to it. So if I wanted to solve for y, I would add 10 to both sides. 10's cancel and y is equal to 25. All right. Next one over here, 5a equal to 13. So 5a means 5 times a. So if I have multiplication, that means I need to do division. And I don't know why I have red right here. It's all good. So we're going to divide both sides by 5. And so notice our answer is 13 over 5. 13 divided by 5 is our answer. So 5 does not divide into 13 evenly. 5 does not divide into 13 evenly. So I can leave it like that. Let me see something real quick. All right, Ms. Dawn, let me know if you can see me now. So I don't know if you're straight or not. So 13 divided by 5. 5 cannot divide into 13 evenly, so it's okay to leave it like that. You do not have to convert it to a decimal. You do not have to convert it to a mixed number. They assume at this point you guys are pros at doing that, so they do not make you do that. But you are expected to reduce your fractions. So reducing and converting something to a decimal are two different things. So here, if I have 4 over 6, you are expected to reduce that. In other words, there's a 2 that's in the 4 and in the 6. So make sure you take it down to 2/3. The 2's can cancel, leave you with just 2/3. That part, like I said, is expected. You do not have to convert to decimals or mixed numbers. All right. So last one of the one-step equations, we have x over 9 equal to 11. And so x over 9 is x divided by 9. So I'm going to multiply both sides by 9. And x is equal to 99 for a solution. All right, any questions before we add more to it? All right, so the next one, 2x plus 1 is equal to 17. So now we have two operations being applied to our x. We have 2 times x plus 1. So we want to remove the 2 and the 1 from the left side of our equation. Now, if we wanted, we could divide both sides by 2 first. It's not the best practice because now you notice we're creating fractions unnecessarily. So the best practice is to subtract 1 from both sides first. So the 1's cancel, leaving you with 2x equal to 16. Then divide both sides by 2. X is equal to 8. All right. Okay. Okay. Sorry, I had one of your classmates email me trying to make sure everybody can get in here. All right. So any problems with that one? Pretty good. All right. So this next one, 2 times x minus 3 minus 17 equal to 13 minus the quantity of x plus 2. All right, so first thing we want to do is go ahead and distribute. In both cases. So distribute the 2, that'll give us 2x minus 6 minus 17 on the left side of our equation. Then distribute 3, and that'll be 13 minus 3x minus 6 on the right side. Now, before I move anything across this equal sign, what I would do is go ahead and simplify as much as I could on the left side, simplify as much as I could on the right side. Now, you can move things before you simplify. I'm just telling you what I would do. In other words, I would go ahead and combine -6 and -17, which will give me this -23. And then I would combine this -13, this 13 and this -6, which will give me 7. So if you just combine like terms on the same side of your equation, you do not do opposite. You just combine the signs accordingly. Remember, you only do opposite signs when you move things across your equal sign. So we have 2x minus 23 equal to 7 minus 3x. Your goal now should be to get all of your terms with x to one side of your equation, all of your terms without x to the other side. Doesn't matter which term you move first or anything like that. If you do everything correctly mathematically, you still should get the same answer. So I'm going to add 3x to both sides. 3x cancels on the right. On the left, if I combine my like terms, I get 5x minus 23 equal to 7. All right. Then from there, you can go ahead and divide both sides by 5. I mean, no, not yet. I'm on the wrong step. We're going to add 23 to both sides. All right. 23's cancel on the left. Then that gives us 5x equal to 30. All right. And then from there, you can go ahead and divide both sides by 5. X is equal to 6. All right. Any questions? All right. All right, so there's the next one here, 5x minus the quantity of 2x minus 10 equal to 35. So we're going to distribute that negative in the same way that we would if it was a number. So that's 5x minus 2x plus 10 equal to 35. So each one of the signs inside of the parentheses will change. From there, combine your like terms. 5x minus 2x gives us that 3x plus 10 equal to 35. Then we subtract 10 from both sides. And that'll give us 3x equal to 25. All right. Divide by 3, and x is equal to 25 over 3. All right. Any problems? Make sure we're all right. Still see writing, so that's all good. All right, see a thumbs up, appreciate it. Scroll up some. All right, so the next one, x plus 2 over 4 minus x minus 1 over 3 equal to 2. So here we have denominators, we have fractions involved. So, you know, some people like to keep fractions, most people don't. So what we're going to do here is to do a process called clearing out our fraction. Am I still holding on to that? Okay, so we're going to clear out our fraction. Now, the first step in clearing out your fraction is to find the LCD. And your LCD is going to be the smallest number that each denominator can divide into evenly. Not what can divide into them, but each one of those denominators can divide into that number that you're calling the LCD evenly. So 4 and 3, smallest number that both 4 and 3 can divide into will be 12. So now we're going to take that 12 and multiply each numerator by it. All right, each numerator we're going to multiply by the LCD. All right, let me erase this. So that's what that would look like. 12 times x plus 2 over 4 minus 12 times x minus 1 over 3 equal to 12 times 2. All right, so now step 3 is to simplify. So what we mean by that is that this 4 can divide into 12 and leave you with 3. 3 can divide into 12 and leave you with 4. So that's the purpose of dividing or multiplying each numerator by the LCD so that your denominators can cancel out into the LCD and you no longer have any denominators. So now this is what we have. 3 times x plus 2 minus 4 times x minus 1 equal to 24 because we have 12 times 2 on the right. And also I didn't emphasize this. Always be careful here. You multiply each numerator by the LCD, everything in the problem has to be affected by the LCD or you are changing the problem. So that means even if it doesn't have a denominator, you still multiply it by that 12 because sometimes people will, you know, miss that number. You know, if it didn't have a denominator, so then they don't multiply by the LCD. Be careful, do not do that. Always make sure you multiply everything by the LCD. So even the 2 needs to be affected by the LCD. All right, so we have 3 times x plus 2 minus 4 times x minus 1 equal to 24. And step 4 is to go ahead and solve it the way we did the previous problems. So we can go ahead and distribute 3 to each problem and to each term of the first quantity. And then here distribute that -4. Don't forget that negative cannot be disassociated from the 4. So you distribute -4. And that gives us 3x plus 6 minus 4x plus 4 equal to 24. All right, combine your like terms. That's 3x minus 4x, which is negative 1x. Then 6 plus 4 will give you 10. That's still equal to 24. Go ahead and subtract 10 from both sides. And that'll give you negative x equal to 14. Don't forget, we're not solving for negative x, we're solving for positive x. So go ahead and take the negative and send it to the other side. X is equal to negative 14. All right, questions, any questions? All right, so that problem will segue us into rational equations, which are basically problems that are, have fractions, equations that have fractions involved, just like the previous problem. But most of the time when you mention rational equations, you actually have a variable in your denominator. All right, so we have 1 over x equal to 1 over 5 plus 3 over 2x. Once again, we want to follow those steps of this clearing out the fraction. So, we need our LCD. So our LCD in this case is going to be 10x. So we're looking at the fact that we have x, 5, and 2. Multiplying those together, they give us that 10x. If we had another situation with the power, we'll see in the future, we come across that, then we have to involve that. But right now, where we got the 10x from was from the x, the 5, and the 2. And so let me erase this. We multiply each numerator by 10x. So that's 10x times 1 over x, 10x times 1 over 5, 10x times 3 over the 2x. So we took the LCD, multiply each numerator by the 10x. So x, yes, so the singular x is counted as the 1x, right? So remember, we want the LCD, we want the smallest common denominator. Now, if I multiplied it together and had 10x squared, that still could be a common denominator that I could use, but it wouldn't be the smallest one. So if we just use one of the x's, that give us the smallest or the least common denominator. So yep, good question. All right. So now we can cancel out. X cancel to x. 5 cancels to 10, it leaves you with 2. And then this 2 cancels into 5, 10 leaves you with 5. And
I have a question.
also this x cancels as well. Yes.
So on the problem before this one, you said that we're supposed to multiply the denominator, but this one we multiplying the numerator. Like, how is that going?
No, we did not numerator. Is that what you're talking about? Did I lose you?
Okay, I see it.
Okay, cool.
Thank you.
Yeah, no problem. I'm glad you asked. All right. So our x is canceled on the first one. 5 canceled out, leave you with 2. 2 cancels into 10, leave you with 5. And then those x cancels as well. And that leaves us with this 10 equal to 2x plus 15. Because I had 10 times 1, which is just 10. 2 times x, 2x, and then 5 times 3. That was left here to give us 15. All right. Any problems? So now we can solve this, regular equation. Minus 15 from both sides. That'll leave us with 2x equal to negative 5 or negative 5 equal to 2x. And divide by 2. X equal to negative 5 over 2. All right, any problems before we go to the next one? All right. So the next one, x over x minus 3 equal to 3 over x minus 3 plus 2. All right. So now we only have one denominator here. Both of them are x minus 3. So that is going to be our LCD. And we will multiply each numerator by the LCD. So it's x minus 3 times x over x minus 3, x minus 3 times 3 over x minus 3, and then x minus 3 times 9. All right. So x minus 3 over x minus 3 cancels. Same thing happens here. And then here we're going to distribute the 9 to each term. And that leaves us with x equal to 3 plus 9x minus 27. All right, any problems? All right, so combine your like terms. That 3 and negative 27 will give you negative 24. Now your goal should be to get, once again, all of your terms with x to one side of your equation, all of your terms without x to the other side. So notice we have 9 that's on the right side with the 24. So let's take the 9x to the left by subtracting both sides by 9x. And that'll give us negative 8x equal to negative 24. Divide both sides by negative 8, and our solution is x equal to 3. Any questions on how we got here? We're almost finished with this. We're not quite finished yet, but before we go any further, make sure we're okay. All right, so x equal to 3. Now remember, we can always plug our value or what we would believe to be our solution back into the original equation to see if it works. If we were to do this or do that with this equation, I plug 3 back into the original equation. Notice I get 3 over 3 minus 3 and 3 over 3 minus 3. I have 3 minus 3 in my denominator, which is 0. I didn't have to get it in both of them, even if it just occurred in one spot. Having 0 in our denominator is not a good look for us, no matter what math class you're in. 0 in your denominator is undefined. You can never have 0 in your denominator. Okay. So what that means for us, since x is equal to 3, since x equal to 3 produces 0 in the denominator, we cannot use it as a solution. We call that being extraneous. It's an extraneous solution. So that means you did everything correctly. You came down, got a value for your solution. Once again, all of your math is correct. But when you plug it back in, it does not work. That's called being extraneous. And since x equal to 3 is our only option for a solution, this means the answer is no solution. So what I mean by that, let's say, and we'll get to a problem like this. I don't think it's next section. I think it's section after next, but we'll see. Might be next section. Anyway, x equal to 3, x equal to 5. I have more than one solution. I have 2 solutions. If I find out that x equal to 3 does not work, then I don't write no solution because I still have x equal to 5. So x equal to 5 will be my only solution. You write no solution when nothing works. So I just want to throw it out there. That's what I meant by that. So I didn't want to confuse that with when we have this type of scenario, one of them don't work and you just write no solution. No, it only no solution when you don't have any other options for a solution. All right. Questions on that? All right. Still see writing, so I'll wait for a second. All right, so go to the next one. We're okay. All right, so the next one, 3 over x plus 2 plus 1 over x minus 2 equal to 4 over x squared plus 4x minus 12. All right, so we have 3 denominators here. First one, x plus 6, second one, x minus 2, third one is x squared plus 4x minus 12. Now, if I were to factor that, I get x plus 6, x minus 2, which is the combination of my first 2 denominators. So remember I mentioned factoring previously. This section doesn't cover factoring. So they are expecting you to know how to factor. So if you know you're a little shaky on factoring, or you haven't seen factoring in a while, you want to see whether it be seeing a lecture on it, or if you want to meet, separately outside of class and talk about some factoring, feel free to email me. Like I said, I have lectures and videos that I've already created for other classes that you can do on factoring. Yep, full, first, outer, inner, last. Yep. So if you want to reduce the factoring process, that's how you would take this, fold it out, and you should get this back. So yep, most definitely. All right. So now with that last denominator, since that is a combination of the first 2, that is our LCD. X plus 2, x plus 6, x minus 2, that is our LCD. So we will take that and multiply that to each numerator. So that's that process right there. Just took that x plus 6, x minus 2, multiplied that to each numerator. And then this last one, I just rewrote the denominator in its factored form so we can cancel out easily. All right. So once again, what this enables us to do is to cancel out our denominators. So x plus 6 cancels, x minus 2 cancels in the next one. And then in the last one, x plus 6 and x minus 2s will cancel. And that leaves us with this right here, just 3 times x minus 6. And 1 times x plus 6 equal to 4. All right. Any problems? And some of the stuff, questions may not come up until you actually get into, doing some of the assignments, some of the work, so that, that's understandable as well. So next, we'll go ahead and distribute 3 times x minus 2 is 3x minus 6. And then 1, of course, times anything is itself. So it'll just be x plus 6 and then equal to 4. Combine your like terms. 3x and x will give you 4x. And then 6 and negative 6 will cancel out completely. So we have 4x equal to 4. divide by 4, and our solution is 1. Any problems? Any problems? All right. Look like we're good to go. All right, you got 2 more quick ones, and you'll see what I mean by quick ones when we go through it. But then we'll be done for today. So this one we have 2x, or 2 times, I didn't even do that, 2 times x plus 1 equal to 2x plus 3. So first thing we'll do is distribute the 2. That'll give us 2x plus 2 equal to 2x plus 3. So now what we can do is, our goal is to get all of our terms with x on one side, all the terms without x to the other. Once again, it doesn't matter which one you move first, as long as you stay correct with your math. I'm going to go ahead and subtract 2x. And so when you have this type of situation, you can't be afraid to let math happen. In other words, what I mean by that is 2x minus 2x cancels on the right. Well, if 2x minus 2x cancels on the right, that means 2x minus 2x also cancels on the left as well. Sometimes people will leave an x right there and they'll have x plus 2 on this left side. But 2x minus 2x cancels on both sides, and that's not a problem. So what that does, that leaves the result of 2 equal to 3, which is false. Now, if you decided to, let's say if you decided to move your 2 first or move your 3 first and then move 2x, you would have either gotten 0 equal to 1 or negative 1 equal to 0. But that doesn't matter. We're not stuck on the idea that it had to be 2 equal to 3. But the bottom line is, do I have a false statement or a true statement once my variables cancel? Okay, so don't matter what the numbers are. It matters, do I have a false statement or a true statement when my variables cancel? So what ends up happening, we focus over here on the blue. When your variables cancel and you get a false statement, your answer is going to be no solution. All right, variables cancel, got a false statement. So that means the answer is no solution. All right, any questions on that? Next one's very similar. So we have 4x plus 6 equal to 6 times x plus 1 minus 2x. Distribute 6. That'll be 6x plus 6 minus 2x. 6x minus 2x is 4x. So really you will have this before you cancel out anything. 4x plus 6 equal to 4x plus 6. Now, once you minus 4x from both sides, you have 6 equal to 6. And I did it purple, I want that in black. Which is true. Or you could have had 0 equal to 0, depending on when you did, what order you did your process. So here your variables cancel. This time you have a true statement. That means your answer is all real numbers. All right. So in this one, anything you plug in for x will be an answer. And the one previous to this, the one that we got no solution, there was no value you could plug in for x. That will give you, that would be a solution or a true statement. All right. Questions on anything?
Yes. The demonstration you just gave us, does that cover all the topics we should be expected to know in section 1.2 in regards to the homework?
Mhm. Yep. Yeah, so yeah, I don't think they will have anything more complicated. But if they do, it's feel free to ask. If you see something that you have a question on, that's what class time is for. Or like I said before, shoot me an email if you want to set up a Zoom session outside of class. You know. Yep, yep, yep. You all right, man? You been yawning the whole class, man. You
Just weird waking up again.
good? I feel you. I feel you. All right. Any questions before we close out? And if you didn't have my email address, btucker@tcc.edu. But once again, you can email me through Canvas as well.
Can we use the all real number symbol?
Let me see. Let me see if I still got my math lab up, because let me see if it'll let me. So here it goes right here. A is the option if you want to put a number in. B right here is all real numbers, and then C is no solution.
Okay.
Yep, yep, yep. Now we'll go litmus first. All right. Yeah, so I will somebody asked a private message about recording. So I will send out this recording before the end of the week, probably on Wednesday. So I'll probably make a recording of both and then send them out to you at the same time. So yeah. So I'll shoot you an email, and then that email, any email sent to you guys will be archived in your Canvas announcements. Canvas announcements. And don't worry about it, it happens. It happens. It happens. Yep, not a problem. Yep, yep. Anything else? Anybody else before we close out today? Everybody good? Everybody straight?
Do we have any work you want us to do, or
Do you have any what? Say it again, a little muffled.
do you have any work you want us to do, like homework or something like that?
Okay, well, you can get started in my math lab. So this is section 1.2 homework. So feel free to jump into math lab and get that work done. You don't have to finish it by next class. For anybody who came in a little late, I will set a due date as we get closer to closing out chapter 1's content. So chapter 1 goes to 1.7. So when we get around 1.5, 1.6, we'll put a due date out there for all of chapter 1's content to be due. And normally my due dates are on a Sunday, Sunday at midnight before it rolls into Monday. That's when everything will be due. So I like to, do that as we move and progress. So to be according to this class, not necessarily a date that I may have to change later on. So, the sooner you get in the math lab, that's where all your work will be. Sooner you get in there to knock the stuff out, the better. And you can move on from there. You don't have to wait for me if you want to move ahead. Let's say you're feeling it tonight and you want to jump into 1.3, feel free to do so. All of your assignments are open to knock out. Anything else? Anybody else? Before we close, everybody good? Everybody straight? All right. So that's it for today. That's 1.2. Like I said, feel free to try this stuff out. If you have any questions that you don't want to wait till next class, always feel free to email me. And other than that, I will see you guys on Wednesday and we'll jump into 1.3. All right. Y'all have a good one.
Good day.
All
Have
right.
a
Thanks.
good
You do the same.
Have a good one.
Thanks.
Enjoy
Take care.
yourself.
Thanks. Do well. Take care. Take care. Miss Dawn, did you ever get back on? Were you able to see the screen? You good? Okay, cool.
I did. I was able to get on,
Okay, awesome.
and it's been 10 years since I've done math. So expect lots of emails from me.
Okay, not a problem, not a problem. So I'll be talking to you.
All right.
All right, y'all take care.
You too.
Oh, somebody said something in the chat. Yep, no problem. Have a good one.